Hello Harlem Lacrosse students. In this video lesson we're going to talk about the Algebra 1 J5 assignment called Solve Advanced Linear Equations. And as the title suggests, this will just start to get a bit more challenging by making the equations a little more complicated, a little more difficult to solve. They might still be two-step equations, one-step equations, but they'll be a little more difficult, or they could have more than two steps in them as well. The first equation that we're going to work with is this equation 9u plus negative 17u equals 8. So I'm going to go ahead and put a box around that right now. 9u plus negative 17u equals 8. And as we move towards these advanced linear equations, we're going to be relying, or at least me a lot, I think as they get more difficult, on using the algorithm or writing the equation out on a piece of paper or whiteboard and taking this step-by-step process to simplify the equation. So I'm going to take this equation, copy it on my whiteboard, 9u plus, and I'm going to use parentheses to show that negative 17u is equal to positive 8. And I'm going to go ahead and draw my river-that line through the equation. And for this first one, I think one of the things that makes this an advanced linear equation or more difficult is that our variable, in this case u, shows up in two different terms this time. And if the variable shows up in more than one term, your job using the algorithm when we're trying to simplify the equation is really going to be to combine those like terms, those variable terms that have the same letter. And if the variable terms are on the same side of the equation, like we see here, if the 9u and the negative 17u are on the same side of the equation, then they can be combined. They're like terms. And in this case, another challenging part is that they're making us do positive 9 combined with negative 17, or 9 minus 17. And hopefully some of us remember when I do 9 minus 17, if 17 minus 9 gives me 8, then 9 minus 17 is going to give me negative 8. And in this case, since there's 9 u's, and we take 17 of them away, if 9 minus 17 is negative 8, 9u minus 17u is going to be negative 8 copies of u. The right side of our equation remains unchanged. It's still that positive 8 over there. And now it says negative 8 times some number u has to give us positive 8. I'm going to solve this with inspection. I know negative 1 times negative 8 would give me positive 8. So I know that u is negative 1 by using inspection, by just thinking about this statement. If I didn't know that, the opposite of multiplying by negative 8 is to divide by negative 8. So if I divided both sides of this equation by negative 8, that would cancel out the coefficient and leave me with just u. And positive 8 divided by negative 8 would give us negative 1, just like we saw from inspection a second ago. So that's how I arrive at an answer here of u is equal to negative 1. I would recommend, if you're at home, before you plug these in as the answer on IXL, because you get through these assignments a lot more quickly if you avoid mistakes, I would definitely recommend plugging your answers into the original equation, seeing if they work. But in the interest of time, I'm going to skip that piece. Our next equation says negative 17j plus 19j is equal to negative 20. And there's no way for me to get rid of that, so I'm going to have to X that out. Oh well, we'll get over it. So that writing's kind of going to disappear now. Well, we can move it to there, actually. No, it's all going to disappear. I'm sorry about that. But you don't really need that writing anymore anyways. Alright, so our equation, negative 17j plus 19j, is equal to negative 20. And so if that's our equation, negative 17j plus 19j, and I need a new marker clearly, I need to see that the j shows up twice. And again here, the j shows up twice on the same side of the equation. And if those j's are on the same side, I can combine them. I can do negative 17j plus 19j. And a helpful thing to realize about math here, negative 17 plus 19 is the same thing as positive 19 minus 17. And that's how my brain's thinking about it. I know 19 minus 17 is positive 2. So that's how I know negative 17 plus 19 gives me positive 2. I can flip two like terms, their order, if I keep the sign the same. So that brings me 2j equals negative 20. And if 2 times j equals negative 20, some of you may be able to solve that by inspection in your head at this point. That's great. I'm going to divide both sides of my equation by 2, because the opposite of multiplying by 2 is to divide by 2. By dividing by 2, I get the j isolated. I get it all by itself. And negative 20 divided by 2, a negative divided by a positive is a negative. And 20 divided by 2 would give me 10. So that's how I'm arriving at j is equal to negative 10 here. Alright, for the next equation, now they're going to make it a little more complicated. They give us 3 equals, and now we see negative 3 outside parentheses and g minus 20 inside those parentheses. So the way this equation is a little more advanced is it's what we call in math factored form. They're using parentheses. So I'm going to go ahead and mark this up a little bit. In the green box here, if we take a look, I'm going to put a red box around the right side of this equation and just focus on the right expression for a second. What this is saying on my whiteboard and on the red box here, it's saying negative 3 needs to be multiplied with both g and negative 20, or whatever g minus 20 makes is going to then be multiplied with negative 3. Because we don't know what g is yet, there's a few ways to approach this problem. If we're going to solve it by the algorithm, the step-by-step process, which I think is the easiest to do here, we're going to need to free the variable from the parentheses. In fancy math words, we're going to need to take this from factored form and use the distributive property to get it into expanded form. What I mean by that is this negative 3, if I want to get rid of these parentheses, the negative 3 would need to be multiplied back into each term in here. So first the negative 3 would need to be multiplied with g. And if I do negative 3 times g, that gives me negative 3g. But now the negative 3 also needs to be multiplied back with the negative 20. This negative 3 was factored out of both terms, so if I want to get rid of the parentheses, I need to distribute or multiply the negative 3 back with both terms that are inside the parentheses. Negative times a negative 3 times negative 20 is going to produce a positive answer. In this case, negative 3 times negative 20 gives us positive 60. Again, this is not the only way to solve equations in factored form. It's one tried and true method I like. I like to distribute, but sometimes there's an easier way I'm going to show you with some of the factored form equations other than distributing. But this will work every time, just may take an extra step. Now I have 3 equals negative 3g plus 60. I'm going to go ahead, I see that g is on the right side of the equation, so I want to get rid of this positive 60. Now this looks like that two-step equation that we worked on earlier. I'll subtract 60 from both sides. And that tells me negative 3g needs to be equal to whatever 3 minus 60 is. If I know 60 minus 3 gives me 57, then I know 3 minus 60, just the opposite, is going to give me a negative 57. So again, this is, once I've distributed, really a two-step equation. The first step was to subtract 60. And now that I have the negative 3g isolated on the right side of the equation, I want to get rid of the coefficient, get rid of the negative 3. The opposite of multiplication is division. So I'm going to go ahead and divide by negative 3 to cancel out the multiply. That gives me g equals, a negative divided by a negative over here is going to be positive. And if 60 divided by 3 is 20, 57 divided by 3 is going to be 19. So with that, I get g is equal to positive 19. Now, I want to show you another method that can work here, especially for the simpler ones when they're in factored form. A second method you can use if they are in factored form and the equation is simpler, there's not a lot of terms in it like we see here. Here I see that the -3 is multiplied with the g minus 20. That's what's been factored out. And the opposite of multiplication is division. So I could do a divide by -3 to cancel out the -3 that's multiplied with g minus 20. And the reason that's helpful for this one, but not every equation, if I divide by -3, every term in this equation on the left side and right side needs to be divided by -3. This is a simple equation. There are no other terms on the right side of this equation, and the only term on the left side is +3. And because I know that divides evenly, if I divide by -3, I think that's a great step to use for this equation. If there were lots of other terms or some other number here that did not get divided evenly when I divide by 3, I'd probably distribute. But sometimes it's quicker to just divide both sides of the equation by whatever was factored out, and that's what you see me doing here. That gives me g minus 20 on the right side of the equation, and 3 divided by -3 gives us -1 on the left side of the equation. Now you see by taking this step, I have simpler, smaller numbers than if I were to distribute the -3 by multiplication. Now I only have one step left as well. All I need to do is add 20. So what you're going to see here, even though I'm going to get to the same answer, -1 plus 20 gives us that same +19. This method was just a little bit more efficient for this situation. But the first method I showed you will work anytime you have parentheses with factored form. This second method I showed you can get more complicated if you're not comfortable working with decimals and fractions sometimes. All right, our next question. Nothing's in parentheses, so the way in which this is an advanced equation is they're putting more terms in this equation. We see 13a minus 15a plus -9, and all of that's on the left side of the equation. Then the equal sign shows up. Then we have the -3. I'm going to draw the river through this equation, and at this point, this is really where drawing the river starts to become pretty important, or at least having the understanding of where is the equal sign, what's in the left side of the equation, the left expression, and what's over on the right side, the opposite half. Here, most of our terms are living on the left side of the equation. There are 3 different terms, 13a, -15a, and -9. I want to simplify this if I can. I can't combine the -9 with the a terms because it's not a like term, but I can combine the 2 of the a terms. In this case, 13a can be combined with -15a. 13 minus 15 gives me -2. I knew that because I know 15 minus 13 would be 2, and this is kind of the opposite of that. So if 13 minus 15 is -2, then 13a minus 15a will give us -2 copies of whatever a is. We've still got the plus -9. I'm going to write that as a -9. Adding -9 is the same exact thing as subtracting 9, so I'm just simplifying along the way. That needs to be equal to -3. Now that I've taken the step of simplifying, of combining the like terms that I can at the beginning of the equation, it looks very much like the 2-step equations you did on assignment J4. The a lives on the left side, so I want to get rid of the -9 first. I inverse that or cancel it out with a +9. And as always, I do the same thing to both sides of the equation. That cancels out the -9. The only thing we have now is -2a on the right side of the equation. And -3 plus 9 would give us a +6. It's the same thing as 9 minus 3, which makes 6. So now I have -2 times a equals 6. I know 3 times 2 makes 6. And I know a negative times a negative would give me the +6 I need. So I'm going to use inspection here on the last step. Instead of dividing both sides by -2, I realize a must be -3 because -3 times -2 is what would give me 6. Great. So this one also, so I'm going to show quite a few because I think for this one, J5, it's a bit more challenging. They throw many different kinds of trickier linear equations to solve. In this case, they're using fractions again. So one thing I'm going to put on here, really, really important, I'm going to go ahead and add something with text quickly. Fractions are division problems. At the end of the day, fractions are division problems. It's a really important thing to understand. Of course, I've messed up a little bit because you can't see that writing. There we go. Fractions are division problems at the end of the day. So that, as I see this complicated equation that has a variable stuck in part of the fraction, knowing that this fraction really represents division is going to help me solve. So I'm going to copy this equation. 4 is equal to u minus 11 divided by 2. That's what a fraction means. It means division. So I'm going to draw my river, the line through the equal sign, and I see that the u, the variable, is sitting here in the right expression, and I want to start getting the u all by itself. If the u is part of a fraction, the first thing I want to do is get rid of the fraction. And if fractions are nothing more than division problems, then the opposite of division is multiplication. So if I don't want that divide by 2, the denominator, that part of the fraction here anymore, I can just multiply by 2 to cancel out the divided by 2. That turns the right side of the equation into u minus 11. But if I multiply the right side of the equation, I change the right half by doubling it by multiplying by 2. I need to multiply by 2 on the left side as well. So over there I did 2 times 4 to keep the equation true, to keep it balanced on both sides. 2 times 4 gives me 8. And now some number u minus 11 has to give me 8. Some of you may know that by inspection. You may know what number minus 11 equals 8, and then you'd be done. I'm going to go ahead and add 11 to both sides of the equation because that's the inverse operation that could cancel out the negative 11 and help answer the question for me. What number minus 11 gets us 8? Oh, it's 19 minus 11 that would have given me that 8. Again, as always, once you have the equation simple enough that your brain can solve it, you don't need to write out every step you see me doing. But the more complicated they get, the more helpful this step-by-step process becomes in simplifying the equation. I'm not going to continue pressing into more problems. I do think that J5 starts to get more difficult, so if there's any difficult ones you find that this video didn't really help you with, or you're still confused about any of these, please feel free to send me an email. As always, my email is ddoherty3@bostonpublicschools.org. I'll write that for you quickly here, ddoherty3 at, and then you're going to have to put bostonpublicschools.org. Hope the video was helpful. Thanks for watching to the end.